Welcome back to AGRON Info Tech. If you have ever opened a dataset, spotted a column called weight, and thought, can I just ignore this? This video answers that question clearly with a real public survey dataset. Right now, I load the NHANES dataset, which comes from a large health and nutrition survey in the United States. The important thing about NHANES is that it is not collected with a simple random sample. Some groups are intentionally sampled more heavily, and that is exactly why a weight exists for each person. Now, I preview the dataset structure so we can see what we're working with. Along with health variables like body mass index and blood pressure, we also have the survey design variables. We have a weight that tells us how many people in the population each participant represents, a strata variable, and a PSU variable that represents the primary sampling unit. Next, I look at the distribution of the weight itself. As the histogram appears, notice the shape. A small number of participants represent a very large number of people, while many participants represent fewer people. This is the key idea. In the real population, some types of people are rarer, and the sampling design compensates for that. Now, I move into the most important step, defining the survey design object. I create a 4-year weight by adjusting the 2-year MEC weight, because the data combine multiple cycles. Then I define the survey design by providing the dataset, the strata, the PSU identifiers, and the weight variable. At this point, the design object becomes our analysis lens. From here onward, we do not treat the data as a simple table. We treat it as a complex sample. Now I print the design summary. This output confirms that the design knows how the sample was collected. It also reminds us that standard errors and confidence intervals must be computed using the sampling structure, not the formulas we use for simple random samples. Next, I show the practical impact with one clear example. I compute the average BMI the naive way, using a plain mean that ignores survey design. Then I compute the survey-weighted mean BMI using the design object. When those two numbers differ, that difference is not random noise. It is the design correcting the oversampled and undersampled groups, so the estimate reflects the population. Now I switch to a categorical example, race distribution, because survey weights often matter even more for proportions. I compute raw sample proportions first, then I compute weighted proportions. When we compare them, the story becomes obvious. The unweighted sample reflects how NHANES sampled people. The weighted result reflects how the United States population is structured. Before we finish, I want you to leave with one simple rule. If your data come from a complex survey, weights are not an optional decoration. They are part of the measurement. Ignoring them can shift estimates and can also make your uncertainty look smaller than it truly is, which leads to overconfident conclusions. In the next chapter, we keep using this same NHANES survey design, and we start exploring categorical variables properly. You will see how to build survey-weighted frequency tables and clean visualizations that actually represent the population.